Our project title is Thermosetting Plastic as Soil Stabilizer. My name is Dharma Abdullah. I will explain about the introductions of this project. Soil stabilization is a chemical or physical treatment which increases or maintain the stability of a soil and to improve its engineering properties. It is mainly used for pavement and foundation. Thermosetting plastic is a material that strengthens when heated but cannot be molded or heated after the initial forming. Statement. This study is carried out to identify the potentials of thermosetting plastic to stabilize soil like thermoplastic. It is also an option to stabilize soil in cheaper way than buying stabilizer material that costs more in the market. Electrical casing is also abundant and easily found in heavier houses, especially when there is electrical maintenance. The objective of this study is to determine the ratio of mixture of thermosetting plastic and soil. Second, to produce soil sample with thermosetting plastic as stabilizer. Lastly, to test the strength of the soil sample with thermosetting plastic as stabilizer.
My name is Dainur Iza Denasari binti Abdul Malik, matrix number 07DKA1 at F1011. Okay, I will present for you guys about our project methodology. At first, we are going to make advertise, and second, we are crushing our thermosetting plastic that we got, and then we are going to take a soil sample from Polytechnic, and then we dried it. Then we doing soil classification. Then we are doing our test.
Hello, my name is Nurul Intan Hafiza binti Muhammad Tahir, matrix number 07DKA1 at F1071, and I'll present about the results for standard Proctor compaction test moisture density curve without plastic. From the results obtained, it can be seen that there's an increasing value and also a decreasing value at a certain point. For data soil sample A, it can be seen that from A1 to A3 shows an increasing value and reached the optimum point, which is at A3. After A3, it shows a decreasing value. This also applies to data soil sample B. From B1 to B3 shows the increasing value and reached the optimum point, which is at B3. After B3, B4 and B5 shows the decreasing value. It can be observed that the maximum dry density and optimum moisture content for soil sample A is at A3, which the value is 2123 kg per meter cubic and 12% respectively. For soil sample B, which is at B3, where the value is 2065 kg per meter cubic and 12% respectively.
I will present you guys about standard Proctor compaction test with 0.4% thermosetting plastic. Okay. The discussion for this test is from this result shows we can observe the maximum dry density and optimum moisture content for soil with thermosetting plastic at sample A is at point A3, where the dry density 2130 kg per meter cubic and the water content at 57%, while for sample B is at point B3 also, and the water content 15.2% and the dry density 2071 kg per meter cubic. And the full conclusion about the both tests is, in conclusion, based on the research shows we can observe this research are successful. It is because we can compare both samples between soil with thermosetting plastic and soil without thermosetting plastic. The A and B sample of soil with thermosetting plastic shows the maximum dry density and optimum water content are higher than the result of both samples without thermosetting plastic. Thank you.
Greetings to our panels. My name is Nurul Hanis Anwari binti Kamaluddin, 07DKA1 at F1039. So I'm going to present the data, the graphs of direct shear stress test. Okay. The first one is shear stress versus shear displacement with and without plastic. Based on the graphs, we can see that the graph of shear stress versus shear displacement with plastic is higher than the graph of shear stress versus shear displacement without plastic. The 0.4% plastic that mixed into the soil does give an impact in this soil sample. Due to the shear stress maximum values, the sample that mixed with thermosetting plastic had more value of shear stress than the ordinary soil. Next one is void ratio versus shear displacement. Okay, obviously from both of this graph, we can see that the sample with plastic are lower than the sample without plastic, which means the 0.4% thermosetting plastic that mix well with the soil are able to fill in the voids and increase the strength of the soil. Okay, the last one, ratio versus shear displacement. Okay, obviously from both of these graphs we can see that the sample with plastic are lower than the sample without plastic, which means the 0.4% thermosetting plastic that mix well with the soil are able to fill in the voids and increase the strength of the soil. Okay, the last one is shear stress versus normal stress. Okay, as what we can see here, based on the both graph, we can see the difference of the values of cohesive and angle. The graph of shear stress versus normal stress with plastic are higher than the graph of shear stress versus normal stress with the plastic. So it means that the plastic do give an impact on the soil. Okay, in conclusion, we can see here that the plastic that we mix with the soil does give an impact on the soil to stabilize the soil.